So hello guys. So today we'll just implement the Python implementation of the chain rule. So at first I'll just show with just two functions, uh, uh, and then I'll show the same code with three functions. Okay. So here was our code from our last time. So you can recognize that the deriv function is already written. So please check it out that here I have also taken another thing called the list. What list is really a collection of elements, right? So maybe a is equal to 1 comma 2 comma, let's say Sabi. This is a list. Okay, a is a list. Let's say type a list, right? So this is how you define a list. So we'll just define a variable called array function, which is a callable. It takes n dimensional array matrix to be precise, and it also will give out n dimensional array, right? So this is really a user defined type, right? So we'll define chains as a list of these types of array functions, right? Now let's define our derivative, like the chain derivative with a chain variable, which is really a type of chains. What is a chain? What are really chains? Chains are just a list of array functions. Okay, and x is the input, which is a type of nd array, n dimensional array, and this function will return a matrix. Okay, so this is what our we'll try with f1 and f2 composite. So this chain contains two functions, that is f1 and f2. So if you don't really get what I am saying, so just refer the previous tutorial where I have explained the composite functions and the chain rule also. So f1 equal to chain 0 and f2 equal to chain 1. So if there is a list, say suppose a is equal to 1 comma 2 comma 3 comma some random words, so a0 will give me the first element, that is 1. Okay, and a2 will give me the third element. Okay, so the counting starts from 0 1 2 3. so if I give a3, it will give me like grd. Okay, if I give a minus 1, it will count from backwards, right? It will count from backwards, so it also gives me 0. What will it give me? A minus 2, it will give it 3. This is minus 1, this is minus 2. So in forward direction it starts from 0 1 2 3, and in the backward direction it starts from minus 1 minus 1 minus 2 minus 3 minus 4. Let's see what is minus 4. That's 1, right? So this is what I'm using in this thing, that f1 is the function in the first element of the chain, which is an array function, and f2 is the second element. So first we'll just calculate what is f1 of x, right? What is f1 of x? f1 of x is nothing but f1. This is a function whose attribute whose argument is passed as the input array, right? And so what is df1? We also need df1 dx, right? So for that we will call the deriv function, and first element, the first argument is func, which is the f1. F1 is the array function, and it is a callable of same type, right? And in the second variable we'll just input the inputs. What is the input here? That is x, right? So in the first box, which I explained in the previous video, the input is x, right? And the second box is what is called the f2. So df2 by df1, right? That is the second derivative what we need to calculate to find out df2 by dx. That is deriv. What is the function? What is inside that box? It is f2. And what is the input to that second box? It is f1 of x, right? So df2 dx equal to df2 df1 into df1 dx, right? It's really just what we discussed last time. So we'll return df2 dx, right? So now we will first define some functions. Let's say I'll define some function called sigmoid, and we'll see that how it really looks like at first. So x is the argument. It only takes one argument in the array. It returns an np dot nd array, and it returns 1 by 1 plus np dot xp of minus x. So what is it? It is really 1 by 1 plus e to the power minus x. So this is the function. So now let us define some x, which is, I'll define equally spaced values from minus 10 to plus 10, that is minus 10 to plus 10, and spaced equally spaced by 0.001. So there are almost 20,000 values. Okay, so I defined x. So let us just see how sigmoid function looks like. So I'll just plot it and show it to you. So we have already imported this matplotlib.pyplot, which is from that we will be using that plt.show, and this is how it looks really. Okay, so it varies from 0 to 1 at max. So at 0 it is almost maybe 0.5. So this is how sigmoid function looks like. So let us plot how the derivative of sigmoid function actually looks like. Okay, so let's pass the deriv function and sigmoid, and let's inputs as x. Okay, wow, it really looks like a normal distribution kind of stuff, and this is how it looks like. Okay, now we will also use another function, which is the sine function. So let us first define the chain which we'll be using. So let us first define the first function as sine function, and the second function is on the sigmoid. Okay, now we will call the chain deriv, which we will store as c2. There is double chain deriv c2d as chain deriv 2, right? We will pass the chain as the first element, and then we'll pass the input. Okay, let's plot it. plt.plot with x comma c to d plt.show. Oh, so this is almost like what is really happening, and let us just see how it looks if I just interchange them. Okay, that is sigmoid comma np dot sign. Okay, so this is really what is happening around the values of the df2.dx, and we are almost getting the same kind of stuff. And let us just plot x comma deriv, that is sigmoid comma x. Okay, and let us just see how it looks like. Yeah, so there is maybe some differences in the plots, and not visibly that much of differences, because the sigmoid function actually ranges between 0 and 1. So it could be because the sine function also varies between maybe around 0, -1 and +1, and we are really getting the second derivative like that. So let's try with something np.cos. Let's see how that look. Okay, so it looks really a bit different. Just see this part, which is not really a smooth line, kind of different. And let's see how it looks like this. Okay, so we are really getting some different values. So it is our code is really working. So we have calculated the chain rule here with two functions. So let us also maybe define square sq function, which only returns the square of that array, right? np dot d array. Okay, so it returns np dot square of x, and so let us just put here sq. Oh, so this is like really a fancy thing which we got. I think it looks really cool, the plot, but let's try with this. Okay, so it's not really different here. So I think this was really cool. Let me just do it another time. Yeah, so this was the chain rule with two derivatives, two composite functions. So let us also define a chain derivative with three functions, right? So first is a chain which contains actually three functions here, f1, like three boxes, right? So this is really chains, and there is input x, which is a matrix, np.md array, and it also outputs a matrix, right? So we will first get out our functions like 0 and f2. We have three boxes, so three functions here, and f3. So we got three functions. First we will calculate df1 dx, which is equal to deriv of f1 with respect to x, right? What is the function we are finding derivative? We are finding the function as f1, and in the input we give x. So now we will calculate f1x, which is f1 of x, right? And this is the input in the box of f2. So df2 dx df1 equal to what is the function, what is the box? Our box is f2, and what is the input? Input is f1, right? And we will also find out f2x, which is needed to find the derivative of the third function. f2x is what is the function f2, and what is the input, that is f1 of x, right? So first the input x is going to f1, and then to f2, and finally in f3, right? So f2x is only f2 of f1x, right? So now df3 df2 equal to derive. What is the box? The box is f3 in this case. And what is the input to the f3 box? F3 box input is f2x, right? And finally we will multiply all these derivatives in the correct manner. First we get df3 df2, then df2 df1, and finally df1 dx, right? And so this will calculate df3 by dx, df3 dx. Now let us define the chain as, let's say, np.cos, maybe xq, and np.sin, right? And let us call the chain derivative 3. Let's just see 3t equal to chain derivative 3. First we give the chain variable, and lastly we give the inputs, right? Now we will plot the function. What is the x? There is x-axis, which is the inputs, then say 3d, and we'll say plt.show, and it is showing like this. So maybe we can just change our orientation, so it still looks like this, because I don't know, because it could be a different thing happening here, and the gradients, the derivatives could be small, could be, I don't know. So this one is really a different kind of thing we are getting. So we are really calculating the df3 dx here. So in this lecture we learned that how to calculate the chain rule in Python. So in the next lecture we'll be learning about finding the parameters in forward pass and in backward pass also. So this was really awesome. I think you can just implement this code in your computer. So stay tuned for the lecture in the next